Okay, so I've had quite a few questions about when carbons are equivalent or not around a benzene ring. So if we look at the example that I've just drawn there with just a benzene ring, if you've not got any substituents on your benzene rings at all, then every single one of those carbons is actually equivalent to one another, and it would just show up as one single peak on a carbon NMR. So if you had a, let's just try that properly, C13 NMR, that's just going to give you one single peak. If, however, you've got a substituent on that benzene ring, so let's say we've got a benzene ring, let's not put a carbon on there at the moment, let's put an alcohol group on there like that. So we've now got a substituent on that ring, and I'm just looking for some coloured pens. There we go. And now we've got a situation where this carbon here is one carbon environment. That carbon is attached to the two carbons there and there, but it also attached to the oxygen. These carbons, in fact, we've got a line of symmetry going through here, and we're always looking for lines of symmetry when we're looking at this sort of problem. So these two carbons, if I just circle that one there and that one there, they are actually exactly the same because they have got that carbon, which is attached to an oxygen attached to it, and they've also got the rest of the benzene ring, and similarly that one. So they're symmetrical, and that's a second carbon environment, but they're both identical to one another. So they're different to carbon environment number one, but the same as one another. Moving around the ring, you might think that this one here and this one here are the same as number two, but in fact they're not in this case, because this carbon has not got an OH attached. It's just a CH here, whereas this, we've got the CH and then round to the C that's attached to the alcohol group. So that's a different environment yet again. So that's carbon environment number 3. And finally, if we move around the ring, we've got a fourth carbon environment here. So 4 separate carbon environments. So on a carbon 13 NMR, this would give you, let's find my other pen, it's a bit better than that one. So your C13 NMR, that would give you 4 peaks. Now, let's just go to another example, quite similar. If you had this example, now you can see we've got, probably because of the way we've drawn it here, it looks as though that it's not quite so, but where we only had one line of symmetry kind of going down the middle of this one, we've actually got 2 lines of symmetry with this one there and one across the centre of the ring that way. So in this case, if we had this compound, that carbon environment and that carbon environment are equivalent, so that is one carbon environment, and the other 4 carbons are equivalent to one another. Each one of those, let's just call them carbon environment number 2, each one of those carbons is attached to a carbon with an OH group attached and a CH with the rest of the ring attached. Those are all exactly identical to one another. So that particular compound would only give you 2 peaks on a carbon 13 NMR. Okay, let's move on to another example. See if I can find a board, otherwise I'll have to write that one clean. I have another board. Okay, let's just slide a new board in here. Okay. Let's have a new benzene ring. of a CH3 group on the top this time. And this time we've got another carbon environment which we didn't have with the previous ones, because this carbon here is a carbon environment all of its own. So there's carbon environment number 1 with this one. Number 2. These two are equivalent, they are exactly identical to one another, so that's environment number 3. These two are also equivalent to one another, but not the same as number 3, so that's the carbon environment number 4. And finally, we've got carbon environment number 5 at the bottom. So here we've got even more carbon environments. So on our carbon 13 NMR this time, we've got 5 peaks.